We're beginning a lab called How Unbalanced Forces Affect Acceleration. We're going to use a PhET simulation tool called Forces in Motion to do this study. And so the first thing you'll need to do is to click on the link here provided in step 1 at the top of the lab packet. When you click that link, it will take you to the simulation tool called Forces in Motion, and we are going to work with the acceleration module. That is on the right hand side, so click that acceleration module to go to there. It looks like this. Let's talk about how to set this up for what we're going to need to do. You need to check all of the boxes in this yellow form except for speed. So notice I put checks next to forces, sum of forces, remember that's the same thing as the net force, values, masses, and acceleration. Take the value of friction to none. So slide this little rocker switch all the way over to none. And one other thing that you need to do, by default, it is set up in the run mode. See this little button with the run symbol. I'm going to click this, and so it will now wait for me to click this arrow before it begins running. That way I'll be able to change the value of the applied force and then run it when I'm ready to record the data. Okay, let's go back and look at the instructions. We've got it set up now. Okay, so we have just completed steps 1 through 3, and now we're getting into the first experiment. In this lab, there are actually 2 possible independent values that affect acceleration, and so we're going to have to examine them one at a time in order to have a controlled experiment. And in this first experiment, we're going to look at how net force causes acceleration to change. So our independent variable is going to be net force, which will be measured in newtons, and the dependent variable will be acceleration, which is measured in newtons per second squared. So it's in step 4, it asks us to select one of the crates and record its mass. So by default, the simulation has a crate here, and it has a 50 kilogram mass. I'm just going to work with that crate. You could replace it with this refrigerator, or you could add another crate on top of it, but I think it will work fine just to use the 50 kilogram mass. So I'm going to record that. Let's see, we've already done steps 5 and 6. Now it asks us to draw a qualitative force diagram for the mass. So let's look at this. I've got a box sitting here on this conveyor belt, and when I apply a force, I'm going to let me put 50 newtons. I see that the man starts to apply 50 newtons to the right, and so this gives me the situation that I need to use for the force diagram. Okay, so I'm going to start by drawing my coordinate axes. So there is a force of gravity on the crate. And since the crate has a mass of 50 kilograms, it has a weight of 490 newtons. The conveyor belt is exerting a normal force that supports that weight. And the man is applying a force. So there is an applied force on the crate by the man. Right now I think that's set at 50 newtons. And those are the only forces. If you notice, the applied force of 50 newtons is the same as the sum of forces in this situation because I set friction to 0. And so therefore there is no force going to the left that's trying to pull, that's opposing the motion of this crate. In the vertical direction, the crate is not moving, and so the normal force and the gravitational force are balancing each other. And so we have a situation where the net force is pushing the crate to the right. And so the net force equals the applied force. The net force equals the applied force because there is no friction. Therefore, when I choose a value of applied force, that is also going to be the value of the net force. Okay, so to begin with, I'm applying a force of 50 newtons, and it tells me that that is also my net force. I'll just go back one more time to show that. Both the orange arrow, which is the applied force, says 50 newtons, and the green arrow, which says sum of forces equals 50 newtons. Now I'm going to click the play button, that's the little arrow, just for a second. When I do this, you will see the value of acceleration over here near the left-hand cloud is going to update. Okay, so I'm going to click play, and I see the crate start to move to the right. I'm going to stop now, and I can read the value of the acceleration. It's 1 meter per second squared, so I need to record that. Now I'm going to go back and change the value of applied force and record a new level of acceleration. So I'm going to click this arrow. It'll take it up to 100 newtons. If you want to do finer differences, you can use the small arrows. Like here, I can make it 101 or 102, but I think I'm just going to use 100 newtons. I'm going to go in these steps of 50 newtons. Okay, so now I'm applying 100 newtons of force, and my net force is 100 newtons. So I'm going to record that. And I will go back and run the simulation for a second. So I click the play button. Just a second is okay. Now I see that the acceleration is 2 meters per second squared. Okay, so you will need to repeat these steps until you have filled this table in with 10 values of applied force.